In this lecture, we are going to discuss about the star-delta transformation, the formula used for converting star to delta and delta to star. And then we are going to solve some problems. And then we'll solve some problems given in the previous year gate questions. So this is the representation of the star network. So the star is also called as Y-connected network. Okay, this is the representation of delta. The resistor which is connected to the terminal A is RA, and the resistor which is connected to terminal B is RB, and that to C is RC. Similarly, here the resistor connected in between the terminals A and B is RAB, B and C is RBC, and C and A is RCA. Okay. So now we'll discuss the formula for converting star to delta. So now we are given with the star resistance, that is RA, RB, and RC are given. Okay, we have to find out RAB, RBC, and RCA. That is the delta equivalent. So the formula for finding out RAB is RA-RB plus RB-RC plus RC-RA divided by RC. Okay. So now we have to remember in such a way that it is multiplied in sequence. That is, we have to consider the sequence as ABC. So first we have to multiply AB, then BC, then CA, and we have to add them all. Okay. This numerator will remain the same for all the values of resistors, that is RBC as well as RCA. RA, RB plus RB, RC plus RC, RA divided by RC. So here, if you see here on the left hand side, we have R suffix AB. Here the missing term is C. So we have to consider that missing term and divide with the RC value. So this is one way to remember this one. Here the numerator will remain the same, and we have to divide them by the missing terminal resistance. Okay. So similarly, RBC can be written as numerator same. Okay, we have to multiply the resistors in sequence RA, RB plus RB, RC plus RC, RA divided by RA. So here on the left hand side we have BC, the missing term is A. So here RA. Now the third one, RC is equal to RA, RB plus RB, RC plus RC, RA divided by RB. So here we have CA, missing term is B, so divided with RB. Okay. So in the case of converting star resistors to delta connected resistors, the numerator will remain the same, and in the denominator we have to divide them with the missing terminal. Next, conversion of delta to star. So this is the delta connected resistors. So here we are given with RAB, RBC, and RCA. So now we have to find out RA, RB, and RC. Okay. So this is the formula for finding out RA. So in the numerator we have RAB multiplied by RCA. So if you see here, RA is the resistor connected with the terminal A, right? So here RAB and RCA are the adjacent resistors to RA. So in the numerator we have to multiply the adjacent resistors and then divide them by the sum of all the delta connected resistors. Here RAB, RBC, and RCA are the delta connected resistors, so we have to add them in the denominator. Okay, in the case of delta to star conversion, the denominator will remain the same, whereas in the previous case the numerator will remain the same. So next, if we want to find out RB, so in if you see here, this RAB and RBC are the adjacent resistors connected to the terminal B. Okay, so we have to multiply these two resistors and divide them by sum of all the delta connected resistors. Okay. Similarly, for finding out RC, we have to multiply these two adjacent resistors, that is RBC multiplied by RCA divided by sum of all the resistors. So now we'll solve some problem. The first one is transform a set of star connected identical resistances into a delta connected resistances as shown in figure 1. So this is a star connected resistors whose value is R. Okay, 3 identical resistors are connected in star. So first we'll write the given data. So here the resistor which is connected to terminal A is RA, and this is RB, and this is RC. So all the values are equal here. So we can write RAB is equal to RBC, RB is equal to RC is equal to R. So now we have to find out RAB, RBC and RCA. So we already know the formula. RAB is equal to RA-RB plus RB-RC plus RC-RA divided by RC. So we have to remember the sequence for the numerator and divide by the missing term over here. Okay. So here all the values are same. So all the values are equal to R. So we can substitute R over here. So R into R plus R into R plus R into R. So R into R is R square. So R square plus R square plus R square will be equal to 3R square. In the denominator we have R. So 3R square divided by R. So R and R will get cancelled and the remaining term is 3R. Okay, this is RAB. Similarly, RBC and RCA are of same value because the given value is same. Okay, so here again, this is the formula for finding out RBC. So here again, we can substitute the R value. So R into R plus R into R plus R into R divided by R. That is equal to 3R square by R. And on simplification, we'll get 3R. Similarly, RCA. So this is the formula. And if we substitute R value, then we'll get 3R. So now the R connected resistors, R star connected R value of resistors are converted into a delta equivalent. Here the delta equivalent is 3R. Okay. So now the second question. For the circuit shown in figure to find RAB. So this is a circuit. So here we have to find out the equivalent resistance across the terminals A and B. So if you see the circuit here, 1 ohm, 2 ohms and 2 by 3 ohms. These three resistors are connected in star. Similarly, if you see here, this 1 ohm, 2 ohm and 3 ohms. These three are connected in delta. So we can either convert this delta into star or this star into delta. Okay. So for finding out RAB, we have to solve the circuit from the opposite direction without disturbing this particular terminal. So now we'll redraw the circuit as shown here. So these three are connected in delta. Okay, now we can clearly understand if we redraw like this. Okay, so let us consider this as A, B and C. So in the first step, we are going to convert this delta connected network into a star connected network. Okay, so this is the star equivalent. So this terminal is considered as RA. So this is RB and this is RC. Okay, so if we want to find out RA, then we have to multiply the adjacent resistors, that is 1 into 2 divided by sum of all the three resistors. Okay, 1 plus 3 plus 2. Okay. So this is the delta equivalent. So now we'll find out RA, RB and RC. So RA is equal to RAB into RCA divided by sum of all the resistors. So 2 into 1 divided by 2 plus 3 plus 1. So that is equal to 2 by 6 or 0.33 ohm. Similarly, RB is equal to. So here if you see here, this is RB. So RB is equal to RBC into RAB or RAB into RBC divided by sum of all the three resistors. So that is equal to 2 into 3 divided by 2 plus 3 plus 1. That is equal to 6 by 6, which is nothing but 1 ohm. Okay. Similarly, RC. So if you see here, this is RC. The adjacent resistors are RBC and RCA. So RBC into RCA divided by sum of all the three resistors. And then we can substitute the values. 3 into 1 divided by 2 plus 3 plus 1. That is equal to 3 by 6 or 0.5 ohm. Okay, this is the star equivalent. So now if we remember the circuit, so this is the actual circuit. So now we have converted this delta ABC into a star equivalent. Okay. So now we can redraw the circuit as shown here. Okay, this delta gets converted into a star. Already we have this 0.67 and 3 ohms resistors. Okay, so now if you see here, these two resistors are connected in series. Okay, so in a series circuit, the total resistance is given by sum of the resistors. So we can add these two resistors. 0.33 plus 0.67 is nothing but 1 ohm resistor. Okay, so now the circuit is redrawn like this. These two are added and it is converted to a single resistor. So now if you see here, these two resistors are connected in series. Okay, in the case of a series connection, only one end of the resistors are connected, right? End to end connection. So again, we can add these two, 1 ohm plus 3 ohms, that is equal to 4 ohm. So now the circuit can be redrawn in this way. So 0.5 will remain as such, 1 ohm will also remain as such. Now it is reduced into 1 plus 3, that is 4. Okay. So now these two resistors, 1 ohm and 4 ohm, are connected in parallel. Okay. If it is connected in parallel, then both the ends are connected together. So both the upper end as well as the lower ends are. Okay. Then it is said to be parallelly connected. So if the two resistors are connected in parallel, then the total resistance is given by R1 R2 divided by R1 plus R2. This is the formula for finding out the total resistance in a parallel circuit. So now we can find out the value. 1 into 4 divided by 1 plus 4, that is equal to 4 by 5 or 0.8. So these two resistors are converted into a single equivalent of 0.8 ohms. So now again we can redraw the circuit like this, 0.5 ohms connected in series with 0.8. The only one end is connected. So this is series connection. So now the RAB value is given by 0.5 plus 0.8, that is equal to 1.3 ohms. So this is the required answer. So now the third one, find the equivalent resistance between the terminals B and C for the circuit shown in figure 3. So this is the figure 3. So here we have given both delta and star. Okay, the outer delta and inner star. Okay, so now we'll try to solve the problem. This is the given problem. So now we will convert the inner star connected resistors into a delta connected resistors. Okay, so now we'll write the given value. So here if we are considering this as A, B and C, so our aim is to find out the equivalent resistance across the terminals B and C. Okay, so we should not disturb this terminals. So we should keep it as such and we have to solve the other terminals. Okay, so we are going to convert the star into its delta equivalent first. So now this is RA. So RA value is equal to 2.4 and this is RB, the resistor connected to terminal B. RB is equal to 3.8 ohms and this is RC. RC is equal to 1.6 ohms. Okay, so now we have to find out RAB, RBC and RCA. So we already know the formula and discussed. Okay, so we have to remember the sequence RA RB plus RB RC plus RC RA divided by RC. Here C is missing, so divided with RC. Now we can substitute the values over here. RA is 2.4, RB 3.8 plus RB is again 3.8 multiplied by RC is equal to 1.6 plus RC is 1.6 multiplied by RA 2.4 whole divided by RC. RC is nothing but 1.6. Okay, so now on simplification we will get 12 ohms. Okay, so next RBC. So this is the formula. Numerator will remain the same. So denominator will be RA. So the numerator values will remain the same. 2.4 into 3.8 plus 3.8 into 1.6 plus 1.6 into 2.4 divided by RA. RA value is 2.4. Now on simplification we will get 8 ohms. And similarly RCA, this is the formula. Numerator same divided by RB. So again we have to substitute all the values over here divided by 3.8. RB is equal to 3.8. On simplification we will get 5 ohms. So now we have converted the inner delta connected resistors into inner star connected resistors into delta connection. Okay, so now we can redraw the circuit this way. Already we have outer delta, now we have inner delta. So if you see here, both the ends of 12 ohm resistor, that is this end, is connected to terminal A, and similarly these two ends, the other two ends are connected to terminal B. So if both the ends are connected together, then it is called parallel connection. See, the upper end is also connected. Similarly, the lower end is also connected together. Okay, such connection is called as parallel connection. So these two resistors are connected in parallel. Similarly, 5 and 5. So if you see here, one end, both the ends are connected to terminal A, and similarly the other end is also connected together to the terminal C. Similarly, these two, 8 and 8, are connected in parallel. So we can simplify them. In the case of a parallel circuit, if two resistors are connected in parallel, total resistance is given by R1 R2 divided by R1 plus R2. So we can apply the same formula over here for finding out RAB, that is 12 into 12 divided by 12 plus 12. So on simplification, it will be equal to 6 ohms. Similarly, RBC is 8 into 8 divided by 8 plus 8. Okay, that is equal to 4 ohms. And then RCA, here we have two 5 ohms resistors. So 5 into 5 divided by 5 plus 5, that is equal to 2.5. So now this circuit gets reduced into a single delta equivalent. Okay, this is the single delta. So now we should not disturb this DC terminal. So if you see here, these two resistors are connected in series. Okay, only one end of both the resistors are connected to the terminal A. So it is series connection, so we can add them. Okay. So now these two, as already discussed, these two are connected in series. So now it can be converted into a single equivalent resistance without disturbing this 4 ohms. Okay, this 4 ohm is nothing but a resistor connected across B and C. Okay, so we have to simplify these two. We can add these two. 6 plus 2.5, that is equal to 8.5. Now both the upper end as well as the lower ends of 4 and 8.5 are connected together. So it is said to be in parallel. Okay, we can apply this formula for finding out the equivalent resistance, R1 into R2 divided by R1 plus R2. So 4 into 8.5 divided by 4 plus 8.5, that is equal to 2.72 ohms. So this is the required value. Now we'll discuss some gate questions. So first one, a star network has a resistance of 10 ohms each in two of its arms, while the third arm has a resistance of 11 ohms. In the equivalent delta network, the lowest value in ohm among the three resistances dash. So here a star network is given and two resistances are 10 ohm and the third one is 11 ohm. So now we have to find out the delta equivalent. In that delta equivalent, we have to find out the lowest value among the three resistances. So this is a direct question. First, we have to convert the star into delta. So here RA is 10 ohms, RB is equal to 10 and RC is equal to 11 ohms. We have to convert them into its delta equivalent, RAB, RBC and RCA. So let us write the given data, RA 10 ohms, RB 10 ohms and RC 11 ohms. So now the formula for finding out RAB is RA RB plus RB RC plus RC RA divided by RC. So already we have discussed how to remember this formula, right? We have to remember them in sequence, that is AB, BC and CA, and add them all and divide by the resistance value which is not present here. That is, if you see on the left hand side, this is AB, suffix is AB. Here the terminal C is missing, so we have to divide it by RC. So in this way you can remember them easily. So now we can substitute the values. RA is 10, RB is 10, okay, 10 into 10, plus again RB is 10, RC is 11, so 10 into 11, plus RC is 11, RA is 10. So whole divided by 11. On simplification, we will get 29.8 0.09 ohm. Similarly, we have to find out RBC. So the numerator will remain the same divided by RA. So on substituting the values, we'll get 32 ohms. And similarly, RCA is equal to RA-RB plus RB-RC plus RC-RA divided by RB. On substituting all the values and simplifying, we'll get again 32 ohms. So these are the three resistances of delta network. 29.09 ohms is the smallest value. So this is the answer. So now the second one. A delta connected network with its Y equivalent is shown in the figure. The resistance R1, R2 and R3 in ohms are respectively. So now the delta connected network is given. Okay, now we have to find out the star equivalent. Y equivalent means star equivalent. So the equivalent star is given. So here in place of RA, RB and RC, we are given with R1, R2 and R3. So that is the only difference. Here this is RAB, this is RBC and RCA. Okay. So let's write the given data. RAB is equal to 5, RBC is equal to 15 and RC is equal to 30 ohms. So now we have to find out R1, R2 and R3. So RA, let us consider RA is equal to R1, RB is equal to R2 and RC is equal to R3. So already we know the formula for finding out the star equivalent term. Okay, now if we want to find out RA, that is R1. So we have to multiply the adjacent values of resistors and divide by sum of all the resistors. So here adjacent values are RAB into RCA divided by sum of all the resistors. That is equal to 5 into 30 divided by 5 plus 15 plus 30. So on simplification, we'll get 150 divided by 50, that is equal to 3 ohms. Similarly, RB is equal to RAB, RBC. So here this is RB. So RAB and RBC are the adjacent resistors. Divided by sum of the resistors. On substituting the value, we'll get 1.5 ohms. So next R3 is equal to RC. So the adjacent values of resistors are RBC and RCA divided by sum of all the resistors. Okay, so on substituting the values 15 into 30 divided by 5 plus 15 plus 30, we'll get 450 by 50, that is equal to 9 ohms. So now we have converted the delta equivalent into star. So now the third question is, if each branch of a delta circuit has impedance √3 into Z, then each branch of equivalent Y circuit has the impedance. So these are the options given. This is again a straight problem. Here the delta equivalent is given, whose values are of same, okay, √3 into Z. Now we have to convert them into the star equivalent. Okay, star equivalent is also called as Y equivalent. So this is again the direct question. Okay, so we have to convert RAB, RBC and RCA into RA, RB and RC. Okay, so here all the values are same. So all the three star connected resistors will have the same value. RA will be equal to RB, it will be equal to RC. So if you want to find out RA, then we have to multiply the adjacent resistors and divide by sum of all the three resistors. Okay, so √3Z into √3Z divided by √3Z plus √3Z plus √3Z. So now √3Z into √3Z divided by, so this is 3 into √3Z. Now the √3Z and √3Z will get cancelled. And we can write this 3 as √3 into √3 in the denominator. In the numerator, we have √3 into Z. Again, this √3 and √3 will get cancelled. The remaining term is Z by √3. So this is the answer, option A. Okay. So this is again the direct question. We have to convert delta into star. So now the next one. Consider a delta connection of resistors and its equivalent star connection. As shown below, this is the delta connection and this is the star connection. Okay. If all elements of the delta connections are scaled by a factor of k greater than 0, the elements of the corresponding star equivalent will be scaled by a factor of dash. Okay, so these are the options given. So here this is the delta equivalent. So it is given that if the delta connected resistors are scaled by a factor of k, scaled means multiplied by a factor of k, then the elements of the star equivalent will be scaled by a factor of dash. Okay, we have to find out the star equivalent and identify how much it is being scaled. Okay, so now let us consider this as a delta. So now we'll assume R as a resistors. Okay, equal value of resistors are connected in delta R ohms and R ohms. So this is RAB, this is RBC, and this is RCA. So now we can convert this delta into star equivalent without multiplying it with K. Okay. So this is a formula. If we want to find out RA, so RA is nothing but the resistor connected to the terminal A. So if we want to find out this one, then we have to multiply the adjacent values and divide by sum of all the resistors. Already we know the formula. So now on substituting the values R into R divided by R plus R, this will be equal to R square by 3R. So R will get cancelled and the answer is R by 3. So in this case, RA is equal to RB and that is equal to RC. So because we have identical value of resistors connected in delta, so the star connected resistors will also be identical. Okay. So if R ohms of delta connected resistors are converted into star, then it will be equal to R by 3. Okay. So now we are scaling the delta connected resistors by K. Scaling means multiplying. So we are multiplying this R with K. So here we are going to consider KR, here again KR, and here again KR. So in place of R, we are going to substitute KR. Okay. So KR into KR divided by KR plus KR plus KR. Okay. So KR into KR will be K square R square. Here KR plus KR plus KR is 3KR. Okay. So now this 1K and this K will get cancelled. Similarly, R and R will get cancelled. So remaining term is KR divided by 3, or this can be written as K times R by 3. Okay. So when we have considered only the R value, the star equivalent is R by 3. Now if we have scaled or multiplied the R value by K, then the star equivalent is K times R by 3. So the star connected resistors are also increased or scaled by a factor of K. Okay, will be scaled by a factor of K. So K is the answer, option B. So now the next one, in the given circuit, each resistor has a value of 1 ohm. So this is the circuit. So here it is a combination of star and delta connected resistors. Okay. All the resistors are of 1 ohm each. What is the equivalent resistance across the terminals A and B? So we have to find out the equivalent resistance across the terminals A and B. Here these are the options. Okay. So now we'll find out the solution for this. So if you see here, we have delta inside and delta outside also. Okay. So if you want to find out a resistance across any two terminals, then we have to start solving from the opposite direction without disturbing this particular branch. Okay. So now we'll solve it from inside. So now we'll first convert this delta, okay, into its star equivalent. Okay. Now we are going to convert this inner delta into star. Okay. So let us consider this as A, B, C, and the values are already given, 1 ohms. Okay. RAB, RBC, and RCA are 1 ohm each. So now we are going to convert them into star, RA, RB, and RC. So if you want to find out RA, then we have to multiply the adjacent values, 1 into 1 divided by sum of all these three, 1 plus 1 plus 1. Okay. So here all are of same value. So RA is equal to RB is equal to RC. That will be equal to 1 into 1 divided by 1 plus 1 plus 1. So this will be equal to 1 by 3. Okay. So now we have converted this delta into a star equivalent. Okay. Already we have 3 resistors here. Okay. One here, and another one here. Okay, so now we'll draw the equivalent circuit. Okay, so this is the inner star. Okay, already we have 1 ohm here and 1 ohm here. So if you see the equivalent circuit, these two resistors are connected in series. Again, these two are in series and these two are in series. If two resistors are connected in series, then the equivalent or the total resistance is given by sum of these two resistors. Okay, so we'll add them. 1 plus 1 by 3 is equal to 4 by 3 ohms. So this inner star gets converted into a single resistor. Okay, connected in star again. Okay, so now we have star inside and delta outside. So our aim is to find out RAB. So again, we will convert this inner star into delta equivalent. Okay, so since all the values are of same, RAB, RBC and RCA will also remain the same. That is equivalent delta for the inner star connected resistors. So this is the formula. Already we have discussed the formula RA into RB plus RB into RC plus RC into RA divided by. So if you want to find out RAB, we have to divide this by RC. If you want RBC, then RA. If you want RCA, then this is RB. Okay, here all the values are same, so there is no problem. So now on simplification, we'll get 3 times 4 by 3 into 4 by 3 whole divided by 4 by 3. So now this 1 4 by 3 will get cancelled. Okay, this one and this one will get cancelled. And again we can cancel this 3 and 3. So the remaining value will be 4. Okay, so now we'll again draw the equivalent circuit. Okay, the inner star is converted into a delta whose value is 4 ohms. So now if you see here, these two resistors are connected in parallel because both the ends are connected. Okay, see this end is also connected to the terminal A, and again these two ends are also connected. If both the ends of the resistors are connected, then it is parallelly connected. Okay, similarly these two are parallelly connected and these two are also parallelly connected. So if two resistors R1 and R2 are connected in parallel, then the total resistance is given by R1 R2 divided by R1 plus R2. So we can apply the same formula here. Suppose R1 is 1 and R2 is 4. So we can write it as 1 into 4 divided by 1 plus 4. So on simplification, we'll get 4 by 5. So all these are of same value. So all the resistors will be of same value 4 by 5. So now we can draw the equivalent circuit. So these two delta gets converted into a single delta equivalent of 4 by 5 ohms each. Okay. So now we should not disturb this particular branch because this is directly connected to the terminals A and B. So if you see here, these two resistors are connected in series. So only one end is connected. The other ends are connected to the terminals A and B respectively. So now we can simplify them into a single equivalent resistance. Okay, we can add them together. So now 4 by 5 will remain as such. Now we can add these two. 4 by 5 plus 4 by 5, that will be equal to 8 by 5. So now these two resistors are connected in parallel because both the upper end as well as the lower ends are connected, right? So now we can find out the RAB value. Okay, if two resistors are connected in parallel, then we can apply the formula like this. Okay, R1 into R2 divided by R1 plus R2. So RAB is given by 4 by 5 into 8 by 5 divided by 4 by 5 plus 8 by 5. That will be equal